also. And I'm sorry for this problem. And in our topic, today's topic, I'm going to start again atomic spectroscopy. I'm going to start the topic again, the atomic spectroscopy. See, the syllabus for CSIR NET JL DL set will be same. Just a minute, I just want to check my audio and video qualities. And thank you for coming my live. Who didn't subscribe to my channel, please click on the subscribe button and also share with maximum number of people, and also click on the like button. మీరు లైక్ బటన్ క్లిక్ చేయడం వల్ల నాకు ఏమవుతుందంటే మోటివేట్ చేసిన వాళ్ళు అవుతారు, ఇంకా క్లాసెస్ తీసుకోవడానికి మోటివేట్ చేసిన వారు అవుతారు. సో ప్లీజ్ క్లిక్ ఆన్ ది like button. And coming to our today's topic, atomic spectroscopy, the syllabus for atomic spectroscopy for each and every examination will be same. Not only atomic spectroscopy, complete physics syllabus will be same for your CSIR NET, UGC NET, and set examinations and JL, that is for Gurukulam or NVS or EMRS, that is Eklavya Model Schools also, DL. So JL, DL set, UGC NET, CSIR NET. For every examination the syllabus will be same for physics, but the typical level changes. Okay, coming to the typical level, set examination is easier than all the above examinations. Okay, set is easier, and then after JL and DL, and then after you will have UGC NET, then after GATE, and then after CSIR NET examination. This is a order of the typical level of your examination. Okay, CSIR NET will be harder when compared to the set examinations. So you just go through my lectures, it will be enough for you. In my live lectures, what I'm doing is I will share or I will teach the theory part maximum. Okay, and I will post my videos, I will upload my videos which are related to problems, so that you can cover the total syllabus for each and every examination. Okay, and coming to our today's topic, atomic spectroscopy. What is an atom and what is spectroscopy? What we are going to learn in this atomic spectroscopy, let's see. So coming to the atom contains a heavier nucleus. We know that atom contains a heavier nucleus. According to Bohr, this nucleus is fixed in space. This nucleus is fixed in space. That means it is not moving. It is at rest position, and an electron will revolve around this nucleus with velocity v in circular orbits. Electrons will revolve in the circular orbits around the nucleus according to Bohr. We know that we have different types of atomic models. One is J.J. Thomson's atomic model, Rutherford's atomic model, and Bohr's atomic model, and Sommerfeld's atomic model. We have different types of atomic models. We are going to discuss all these atomic models in our lectures. And coming to atom, it contains a heavier nucleus, and the electron revolves around this nucleus, and it revolves in circular orbits according to Bohr. And this center part, which is heavier, is a nucleus, contains protons and neutrons, which are positive charges. Okay, neutron is a chargeless element, and proton is a positive charge. Proton is of positive charge and electron is of negative charge. And how to represent this charge? how to represent the charges and how to represent the atom. First of all, we will go for the representation of atom. Atom is represented with x, a, z, x, a, z. Okay, x is an atom and a is the mass number of the atom, z is the atomic mass number. Z is the atomic mass number of the atom. This mass number gives the sum of the protons or electrons and the neutrons. Sum of the protons or electrons and neutrons. Okay, sum of the protons or electrons and the neutrons. Okay, mass number gives us the sum of the protons and neutrons Okay, and coming for the atomic mass number, this gives us the number of protons or the number of electrons. Number of protons will be equal to number of electrons. And coming to the number of neutrons, how to find out the number of neutrons? If you subtract the mass number if you subtract the atomic mass number from mass number, that is A minus Z, then you will have number of neutrons. And coming to the spectroscopy, what is spectroscopy? Spectroscopy helps us to study the motion of electrons and the arrangement of the electrons. It helps us to study the motion of the electrons and the arrangement of the electrons. Okay. For example, according to Bohr, the electrons will revolve the nucleus in circular orbits. Electrons will revolve around the nucleus in circular orbits. Okay, and we have different shells in each orbit. We will learn further. Okay, and coming to the spectroscopy, it is of two types: emission spectroscopy and absorption spectroscopy. Just a minute.
ఏ మహా నువ్వు ఎందుకు వచ్చినావు? క్లాస్ అయితే ఉన్నాడు, వెళ్ళు, డోర్ కొడుతు మళ్ళా.
So coming to the emission spectroscopy and absorption spectroscopy. Spectroscopy is of two types. One is emission spectroscopy and absorption spectroscopy. Scientist Kirchhoff as well as scientist Joseph found that there will be emission and absorption spectrum which is radiated from sun. Whenever we observe the sun rays or the radiation from stars, what happens? You will observe the two types of spectrum. One is absorption spectrum, emission spectrum. In 1814, scientists Kirchhoff and Joseph Fraunhofer, what they did, they observed the emission spectrums and absorption spectrum in the radiation of the stars and sun. So from there we found that spectroscopy is of two types. One is emission spectroscopy as well as absorption spectroscopy. And what is emission spectroscopy and what is absorption spectroscopy? Let's see. So first one, as we know that electrons revolve around the nucleus in circular orbits. In this lecture, I am taking that electrons will revolve around the nucleus in circular orbits only. Why? Because here I am going to discuss about the Bohr's atomic model only. Okay, in this lecture, I am taking the electron will revolve around the nucleus in circular orbits. Okay, so as the electron will revolve in the circular orbits, and each atom contains number of orbits, that is infinity orbits. Okay, each atom contains infinity orbits, and according to the atomic mass number, we will have the valence orbits or so on. So whenever the electrons revolve around the nucleus in their circular orbits, okay, with velocity v, what happens? As the light rays illuminate continuously the atom, what happens? The electrons will transverse to the higher energy levels by observing the energy from these light rays. Okay, h nu energy, they observe the energy h nu and will get transversed to the higher energy states. Okay, I'm taking here, this is the this as the first excited state, this orbit as the first excited state, and this is the ground state. Okay, by observing the energy, what happens, these electrons will transverse to the higher energy orbits, and because of that, what happened here, the energy is absorbed by the electron. Here energy is absorbed, that means we are going to have the absorption spectrum here. In this case, we are going to have an absorption spectrum. In this case, we are having absorption spectrum. Here we having absorption spectrum. Absorption spectrum. What is an absorption spectrum? Now, dark lines will be observed on the bright background. We have a bright background, and in front of this bright background, we have the dark lines. We have the dark lines. Okay, this is an absorption spectrum. Here, dark lines are formed due to the absorption of the energy. Okay, and on the behalf of the bright background, on the bright background, we are having the dark lines. This is known as absorption spectrum. And coming to the emission spectrum, so after transmitting of this electron from lower energy level to higher energy level, what happens? The electron will stay there up to 10 power minus 8 seconds only. Then after, what happens? It will move to the ground state again. It will move to the ground state again. From the first excited state, it will move to the lower state, that is ground state, by radiating the energy. ఇక్కడ ఎనర్జీ రేడియేట్ చేస్తేనే మరి ఎలక్ట్రాన్ లోయర్ ఎనర్జీ లెవెల్కి ట్రాన్స్ఫర్ అవ్వగలుగుతుంది. వై? బికాస్ whenever this electron is moving to the ground state, what happens? It will carry some energy. How much energy? The energy is, if this is the initial state and this is a final state, this electron carries the energy of E initial minus E final. E initial minus E final. ఓకేనా? ఇక్కడ ఇనిషియల్ ఆర్బిట్లో ఎంత ఎనర్జీ ఉంటుంది, ఫైనల్లో ఎంత ఎనర్జీ ఉంటుంది, ఆర్బిటాల్స్లో ఎంత ఎనర్జీ రిక్వైర్మెంట్ ఉంటుంది. ఓకే, ఆ రిక్వైర్మెంట్ని మనం సబ్స్ట్రాక్ట్ చేస్తే మనకు వచ్చే ఎనర్జీ ఏదైతే ఉందో అంత ఎనర్జీ ఆ ఎలక్ట్రాన్ క్యారీ చేస్తుంది. ఐ విల్ ఎక్స్ప్లెయిన్ దిస్ పాయింట్ ఇన్ దిస్ లెక్చర్ అగైన్ క్లియర్లీ విత్ వన్ ఎగ్జాంపుల్. ఓకే, హైడ్రోజన్ ఆటమ్ ఎక్స్ప్లెయిన్ చేసినప్పుడు అక్కడ మీకు ఈ పాయింట్ క్లియర్గా అర్థమవుతుంది. ఎనర్జీ ఎంత, ఎలక్ట్రాన్ ఎంత ఎనర్జీ క్యారీ చేయాలి ఎగ్జైట్ అవ్వనికి కానీ లోయర్ ఎనర్జీ లెవెల్కి మూవ్ అవ్వనికి కానీ. ఓకే, సో యాజ్ హియర్ ద ఎలక్ట్రాన్ ఈజ్ రేడియేటింగ్ ఎనర్జీ ఆఫ్ h nu. Okay, as here emission is taking place, emission of radiation is taking place, you will have an emission spectrum here. Here you will have the emission spectrum. I will go little faster. Why? Because we have a lengthy syllabus ఉంది. ఆ lengthy syllabus మనకున్న టైంలో కవర్ చేయాలంటే నేను లిటిల్ ఫాస్టర్గా వెళ్ళాల్సింది, క్లాస్ ఫాస్ట్గా చెప్పాల్సింది. ఓకే, హియర్ వీ విల్ హ్యావ్ ద ఎమిషన్ స్పెక్ట్రమ్. అండ్ కమింగ్ టు ద ఎమిషన్ స్పెక్ట్రమ్, bright lines on the dark background. You will observe the bright lines on the dark background. You will have the dark background, and on this dark background you will have the bright lines. లైన్స్ ఫామ్ అవుతాయి మనకి. లైన్స్ కంటిన్యూస్ స్పెక్ట్రమ్ కాదు. కంటిన్యూస్ స్పెక్ట్రమ్ అంటే ఎట్లా ఉంటుంది? దిస్ విల్ బి ద కంటిన్యూస్ స్పెక్ట్రమ్. ఓకే, ఇక్కడ నుంచి ఇక్కడ వరకు కూడా కంటిన్యూస్ స్పెక్ట్రమ్ ఉంటుంది. మనకి కంటిన్యూస్ స్పెక్ట్రమ్ ఉండట్లేదు, లైన్స్ ఉంటున్నాయి. lines, series of lines. You will observe the series of lines here. Okay, yes. So this is about the basic idea of spectroscopy, and you will observe these dark lines and bright lines through the spectrogram. By using a spectrograph instrument, you will observe the spectrum of the atom. You will observe the spectrum of the atom whenever that atom is illuminated by the source of light, monochromatic source of light. Okay, and coming to our next topic, Bohr's postulates. Bohr's postulates. First postulate is electron moves in circular orbits around the nucleus. As I said just now, we have a centered nucleus which is fixed in space of an atom. Okay, and electrons will revolve around this nucleus with velocity v, in circular orbits. Listen carefully and copy in your notebook. You have to maintain your notebook. Okay, then it will be easier for you for your examination, preparation of your examination. And thank you for coming to my live, students. Thank you so much. Okay, so as per the Bohr's first postulate, electrons moves in circular orbits, that too around the nucleus. Electrons will move in circular orbits around the nucleus. Okay, as the nucleus is a positive charge due to protons, and electron is a negative charge, there will be an attractive force between these charges. Which is known as Coulombic force of attraction. Coulombic force of attraction. You will learn this Coulombic force of attraction in electromagnetic theory. Coulombic force of attraction from Coulomb's law. I hope you have an idea of Coulomb's law. We had studied this Coulomb's law in our intermediate as well as in our graduate, right? So this force will be equal to 1 by 4 pi epsilon naught times of Q1 Q2 by R square, right? So here for nucleus the charge will be Ze. Z is the number of protons and E is the charge. Okay, and here we have electron. If I am considering only one electron, then the charge will be E. Therefore, force will be equal to 1 by 4 pi epsilon naught. It is an attractive force due to these charges are unlike charges. Okay, 1 by 4 pi epsilon naught times into Ze into E by R square. If the distance between these charges is R, then this force will be equal to 1 by 4 pi epsilon naught Ze by R square. This can be written as Ze square by 4 pi epsilon naught R square. So according to Bohr's postulate, electron moves in the circular orbits around the nucleus, and the electron will experience an attractive force due to the positively charged nucleus, which is known as Coulombic force. Thomson's atomic model, Thomson said that nucleus positively charged positive charges and negative charges, that is electrons and protons, are arranged in a way that do you remember plum pudding model? That means you will have the plum. Plum is nothing but watermelon. Plum pudding model, watermelon model or plum pudding model. In watermelon, what happens? You will have plum and the seeds of watermelon are arranged in them. In the same way, electrons are arranged in the positively charged plum. Okay, so Thomson considered that positive charge is just like a plum of the watermelon, and electrons are arranged just like the seeds arranged in a watermelon. Okay, according to J.J. Thomson. And coming to Rutherford's model, Rutherford said that an atom is almost empty. With a tiny positive charge at the center. Tiny positive charge located at the center. Okay, and the electron, because of the continuous emission of the energy, what happens? The electron will fall into the nucleus, which is an unstable system. This is a unstable system. This is given by Rutherford. But from this first Bohr's postulate, we can say that the atom contains an nucleus at the center, and the electrons will revolve around the nucleus. And this is a stable system. And coming to our Bohr's second postulate, Electrons will move in those orbits. Electrons will move in those orbits in which it's in which the orbit's angular momentum is an integral multiple of h by 2 pi. h by 2 pi. h by 2 pi. Electrons move in those orbits for which its angular momentum, orbital angular momentum, is an integral multiple of h by 2 pi. In that means, see here we have an integral multiple of h by 2 pi. Integer, n is an integer whose values are 1 to 3 so on infinity. So orbits, that means we are not having continuous energy. We have in this case, in an atom, we are not having the continuous energy here, continuous energy levels. We are having the integral energy levels. That means we are having integral orbits. These are not continuous. Okay, that means this theory is related to quantum mechanics. Quantum mechanics. First postulate is related to classical mechanics, and second postulate is related to quantum mechanics. It obeys quantum principles. Why? Because it's just because we are having integral energy levels, that is discrete energy levels. Okay, and atom contains discrete orbits or discrete energy levels. Therefore, the second postulate obeys quantum principles. It is related to quantum mechanics. Okay, from here you can say that the quantization of angular momentum of the electron. That means here electrons are moving in discrete energy levels. Okay, and as we know that the angular momentum is equal to r bar cross p bar. This can be written as rp sine theta. As the electrons are moving in the circular orbits with velocity v, and this is a r bar, which is a position vector from the center of this orbit, that is from the nucleus. Okay, as these are perpendicular to each other, that is the velocity vector and the position vector perpendicular to each other, here the theta value will be 90 degrees. So therefore from here you can write the L bar as R into P. RP. Why? Because sin 90 is equal to 1. Okay, so here you can write the equation. L is equal to R into P is the momentum. Momentum is nothing but mass into velocity. This will be equal to NH by 2 pi. Okay, keep this equation in a box. We are going to use this equation in our further classes. Okay, and coming to the third postulate. Electron does not radiate electromagnetic energy. Electron does not radiate electromagnetic energy. Hi, good morning to everyone. Good morning Shiva, good morning Padma, good morning Raghu, Manasa, good morning. Good morning everyone. Thank you for coming to my class. Yes, coming to the third postulate, electron does not radiate electromagnetic energy while moving in an allowed orbits. Yes, electron does not radiate energy. See, electron only radiates energy when the transition takes place. Transition of electron from one orbit to the other orbit. Okay, for example, if the electron initially is in ground state, and because of the continuous illumination or because of the continuous light rays, this electron will absorb the energy of h nu and transfer or move towards the first excited state. If the electron moves to the first excited state, then only here you will observe the absorption spectrum. And whenever the electron move to the ground state again, then it will emit energy or radiation of h nu. Okay, so whenever the electron transition takes place, then only it radiates energy. otherwise it won't radiate any energy. That means the orbits are stationary. Here you can say that the orbits are, the energy of the orbits remains stationary. It won't change, remains stationary. It's a very important point. It's a very important point. It might be asked in your examination. Okay, so the energy of each orbit remains stationary until the transmission of electron takes place from one orbit to the other orbit. From here, the problem of stability of the electron is removed. As I said, according to the Rutherford, as a continuous emission of radiation by the electron, what happens? It will move into the towards the nucleus and fall into the nucleus. That means it is an unstable system. To be a stable system, the electron must not radiate energy until it absorbs the energy or radiate energy. ఓకేనా, ఎనర్జీ అబ్జర్వ్ చేసుకున్నప్పుడు లేదా ఎనర్జీ రేడియేట్ చేసినప్పుడు మాత్రమే ఎలక్ట్రాన్ ట్రాన్సిషన్ పాసిబుల్ అవుతుంది. ఎలక్ట్రాన్ ట్రాన్సిషన్ పాసిబుల్ అయితేనే ఎనర్జీ అబ్జర్ప్షన్ లేదా ఎనర్జీ రేడియేషన్ పాసిబుల్ అవుతుంది. ఓకేనా, అదర్వైజ్ ద ఎనర్జీ ఆఫ్ ఈచ్ ఆర్బిట్ రిమైన్స్ స్టేషనరీ. ఓకే, therefore you can say that the system of the atom, that means the arrangement of the electrons and the motion of the electrons remains stationary, and the system is said to be stable system. Okay, and coming to our next postulate, Bohr's fourth postulate, if the electron moves from the higher orbital to the lower orbital, if the electron moves from the higher orbital to the lower orbital, and this higher orbital I am considering as the initial orbit, and lower orbit I am taking it as final orbit. Okay, if the electron moves from the higher orbit to the lower orbit, it radiates electromagnetic radiation. As I said, whenever the electron transmission takes place from higher orbit to the lower orbit, it radiates energy of h nu, which is equal to the energy carried by this electron. Okay, yeah, whenever the electrons remains in this second orbit, that is higher orbit, it will carry h nu energy, and it will radiate this h nu energy to transfer to the lower orbit. Okay, and this is nothing but Einstein's equation, energy equation. So as per Bohr, he had given this equation, that is frequency is equal to initial energy minus final energy divided by h. H is Planck's constant. H is Planck's constant. Okay, this equation is just similar to this Einstein's energy equation. Okay, so you just remember this equation. We are going to use this equation to find out the Rydberg constant. Okay, yes. Next, coming to the Bohr's atomic model. Bohr's atomic model is just for one electron atom. That means example is hydrogen atom. It is valid for only one electron atom. Bohr's atomic model is valid for one electron atom. Why? Because Bohr didn't explain the fine spectrum of the atom. Okay, fine spectrum of the atom is not explained, and he didn't explain the spectrum of the atom if the atom contains more than one electron. He failed to explain. Okay, he just explained the spectrum of only one electron atom. He succeeded to explain the spectrum of one electron atom, and here we are going to find, in Bohr's atomic model, we are going to find the energy of nth orbit and the velocity of the nth orbit, and also the radius of the nth orbit. Thank you, Manasa. So to find out the energy, velocity and the radius for nth orbits, we are going to use these conditions. That is, we are going to consider the nucleus as heavier mass. Nucleus contains heavier mass and it is fixed in space of the atom, and the electron will revolve in circular orbits. Electron will revolve in circular orbits. We are going to consider these points, and we are going to find out the energy, velocity, and the radius of the atom. Energy of the electron in the circular orbit, velocity of the electron in the circular orbit. Here energy of the orbit, not electron. That means of course whenever the electron is in ground state, okay, this electron carries the energy, this electron carries the energy of this ground state, okay. And we are going to find out the velocity of the electron, which is revolving around the nucleus in a circular orbit. And coming to the radius, that means radius of the orbit in which electron is revolving. Okay, we are going to find out these equations using Bohr's postulate. Okay, and yes, I'm considering the first Bohr's postulate. Bohr's postulate. Please maintain your notes. Otherwise, listening to my classes is useless. So maintain your notes and copy all the notes, whatever I'm saying. Whatever the words coming from my mouth, you just write in your notes. It will be helpful for your examination, okay? And coming to first Bohr's postulate, what is Bohr's postulate? L is equal to mvr, which is equal to nh by 2 pi. Okay, integral multiple of h by 2 pi. Orbital angular momentum will be equal to integral multiple of h by 2 pi. From here, I'm taking. Sorry, this is not first Bohr's postulate, right? Okay, sorry. First Bohr's postulate is the electron will revolve around the nucleus in circular orbits. Electron will revolve around the nucleus in circular orbits. Okay, Zg is the charge of the nucleus, E is the charge of this electron, and there will be a attractive force between these two electrons, between these two charges, right, which is known as Coulombic force of attraction, and the value will be equal to Zg square by 4 pi epsilon naught r square, if r is the distance between these two charges. And this Coulombic force will be equal to the centripetal force. Did you remember the centripetal force we found out in gravitation chapter of your 9th class? Did you remember that? That is a centripetal force is equal to mv square by r. Did you remember this? Once go through the gravitation chapter. I had taught in my channel itself. You just go and revise that. Okay, playlist కూడా ఉంది గ్రావిటేషన్ చాప్టర్కి, ఒకసారి చెక్ చేసుకోండి. ఇంటర్మీడియట్ గ్రావిటేషన్ చాప్టర్ టీచ్ చేశాను నేను, ఒకసారి అందులో చెక్ చేసుకోండి. ఓకే, సో ది సెంట్రిపిటల్ ఫోర్స్ ఈజ్ ఆల్సో directed inward. So when and if this mass is capital M and the electron mass is small m, whenever a mass is orbiting in a circular orbit and one more mass is situated at the center, then the direction of the centripetal force will be inward. The direction of the centripetal force will be inward direction. See, both these forces are equal. By to be stable for the system to be stable, both the forces must be equal to each other. So this is first Bohr's postulate. From here, the force of Coulombic attractive force will be equal to centripetal force. Okay, that is Zg square by 4 pi epsilon naught r square is equal to mv square by r. So from here you can write the equation for r, that is a radius. I'm considering here the radius of nth orbit. We don't know whether it is first orbit or second orbit or whatever. I'm taking it as nth orbit, and n can take values from 1 to infinity as it is an integer. So from this equation you can find out the value of r. So rewrite this equation. R is equal to, here we have cancelled, I just cancelled this r and r. So r is equal to ze square by 4 pi epsilon naught, 4 pi epsilon naught into mv square, 4 pi epsilon naught into mv square. Okay, and as we know that the angular momentum L bar equals to n h by 2 pi, and h by 2 pi, and here I am using this angular momentum equation to find out the radius r. That is angular momentum mvr equals to nh by 2 pi. Okay, angular momentum mvr is equal to nh by 2 pi. From here, using this equation, I am going to find out this. So I am writing here ze squared by 4 epsilon naught r is equal to, I am taking r towards right side. So here I have m v r into r, sorry, into v. V into v is v square. Okay, and 4 pi, we have pi here, right, epsilon naught. So mvr equals to nh by 2 pi. I am writing here mvr equal to nh by 2 pi. We have r here, right? Oh, sorry. Yes. So using these equations, if you rewrite this equation, you will have the r value. Sorry, solve this equation. I'm just confused. I'm really sorry. I'm rewriting this equation. So angular momentum mvr equals to nh by 2 pi, and we have ze squared by 4 pi epsilon naught r square equals to mv square by r, mv square by r. So from here mv is equal to mass into velocity equals to nh by 2 pi r. I'm rewriting this equation here, and I'm substituting the mv value in this equation. Mv value in this equation, mass into velocity value. Okay, and if I'm taking this whole square, if I had taken this whole square, okay, I'm writing whole square here, and from here and multiplying and dividing with mass, therefore we have m square v square. Okay, this ze squared by 4 pi epsilon naught r square is equal to n square v square is n square h square by 4 pi square r square, and we have one more r here, right? Now just cancel this 4 pi r square. From here you can write this ze squared by epsilon naught is equal to n square h squared by pi into r, right? From here you can write the equation for r, right? R is equal to ze square into pi by n square h square epsilon naught. I'm sorry for the delay. Just now I made a delay. Sorry, I'm really sorry. So we have n square h square epsilon naught by pi mz e square. Pi mz e square. Is my video clear? Yes, thank you. I'm making little correction for my video. Please. Okay, now it will be clear. So this is the radius of nth orbit. This is the radius of nth orbit. You just keep it in a box, and this will be the equation 1. Okay, using these equations we are going to find out the velocity as well as the energy equations. Okay, from here you can write the equation for velocity. Okay, right. So now the energy equation, how to write the energy equations. Let's see. Just a minute. This is the radius equation, and how to find out the velocity equation. As we know that L equals to mvr, which is equal to nh by 2 pi. From here the velocity is equal to nh by 2 pi mr. 2 pi mr. I'm bringing this mr towards right hand side. Therefore this velocity is equal to, just substitute first equation in this equation number 2. I'm taking this as equation number 2. So substitute equation number 1 in equation number 2 to find out the velocity. Therefore velocity is equal to nh by 2 pi m into what is the radius we have. I'm taking the reciprocal of the radius, that is pi m z e square by n square h square epsilon naught. And therefore the velocity is equal to here pi get cancelled and n cancelled, h cancelled. Therefore we have z e square and also cancelled, z e square by 2. We left with 1 n and h, 2 n h epsilon naught. This is the velocity equation for nth orbit. Keep it in a box. These equations, equation number 1 and equation number 3. This is equation number 3. Both these equations are very important. We are going to use these equations while solving problems. And using these two equations, we are going to find out the energy equations. We are going to find out the energy equations. Okay. So coming to energy equation, coming to the potential energy which is denoted with U. To find out the total energy, initially we have to find out the potential energy and the kinetic energy. Why? Because initial energy is nothing but, the total energy is nothing but sum of potential energy and kinetic energy. Therefore I am going to find out the kinetic energy. So before going to find out this kinetic energy, you have to know the work done. Work done is equal to the scalar. It is a scalar product of force and displacement. Scalar product of force and displacement. From electromagnetic theory you will find out this equation. but I will explain here once again for clearing to clear your doubts. ఇప్పుడు నేను ఈక్వేషన్ ఎక్స్ప్లెయిన్ చేయకుండా వదిలేసాను అనుకోండి, మీకు నెంబర్ ఆఫ్ డౌట్స్ ఎరైజ్ అవుతాయి. సో మీకు డౌట్ రాకుండా ఉండడానికి నేను ఈ ఈక్వేషన్ ఇక్కడ కూడా ఎక్స్ప్లెయిన్ చేస్తాను, అండ్ ఎలక్ట్రోమాగ్నెటిక్ థియరీలో కూడా ఎక్స్ప్లెయిన్ చేస్తాను. ఓకే, ఇఫ్ ఐ హ్యావ్ ఏ సోర్స్ చార్జ్ Q and a unit positive charge at a distance of r from the source charge, and I want to place this unit positive charge at infinity, at a distance of infinity from this charge, source charge. Okay, here if the source charge is negative, then there will be an attractive force, and attractive force, I applied the force in this direction. Okay, therefore the work done will be negative. Why? Because both the forces are opposite to each other. This work done will be negative. And for small amount of work done, that means for small displacement dr, I'm not taking this atom at a time to infinity. I'm not taking this unit positive charge at a time to infinity. I'm just displacing very slowly, so that this atom or this charge should not be accelerated. That means the acceleration must be equal to 0, so that I'm displacing very slowly. Therefore, for small displacement dr, I have small amount of work done. Okay, to find out the complete work done, total work done, I have to integrate this equation. Okay, so from here the work done, the total work done will be equal to minus integral f dot dr. As we know that the force is equal to 1 by 4 pi epsilon naught into q into unit positive charge by distance r square. From Coulomb's force of attraction, you just substitute in the above equation, the work done will be equal to minus integral of, you are bringing this charge from r to infinity, to a distance of infinity. Therefore I am taking the limits r and infinity, 1 by 4 pi epsilon naught into q by r square. Here the q is Zg, right? Zg, it is a nucleus, and unit charge is a electron. Here I am considering the electron. Okay, right. And as the electron, it is not a unit charge, it is having the charge of E. Okay, so in this in place of these charges, I have a nucleus and an electron. Therefore the force between these two charges is 1 by 4 pi epsilon naught times of Z into E by r square dr. Therefore the work done will be equal to, I'm taking the constants outside, Z E squared by 4 pi epsilon naught, here we have minus sign, integral of 1 by r square dr, limits are from r to infinity. Okay, therefore work done will be equal to minus Z E squared by 4 pi epsilon naught. If you integrate this equation, you will having minus 1 by r. Okay, just take the limits and substitute in this equation. It's your work. Okay, you just substitute this and find out this value. Okay, therefore the work done is equal to minus into minus plus Zg squared by 4 pi epsilon naught, 4 pi epsilon naught. Okay, 4 pi epsilon naught into r. See, this work done is nothing but the potential energy. This work done is stored in the form of potential energy. Okay, as the work done increases, potential energy increases. Therefore this work done is nothing but the potential energy. This work done is stored in the form of potential energy. And from the radius equation, I am going to substitute this r value in this equation. I am going to substitute r value in this equation. What is r value for nth orbit? It is n square h square epsilon naught by pi m z e square. You just substitute this equation in this above equation and solve this. I will give you a minute. I have to increase my voice. Okay, sure. I will increase my voice. Okay, is this audible now? Is my voice audible now? I hope so. And did you solve this equation? Did you solve the equation for potential energy? So therefore potential energy U is equal to n square h square epsilon naught. Potential energy is equal to Ze square by 4 pi epsilon naught. Ze square by 4 pi epsilon naught into R. So I'm writing the reciprocal of R as pi mz square. Pi mz square is pi mz square by n square h square epsilon naught. N square h square epsilon naught. N square h square epsilon naught. Okay, therefore the potential energy is equal to pi cancel. We're left with z e power 4, z into e power 4 into pi is cancelled, not m. Okay, into here z into z will be z square e power 4 m by 4 n square h square epsilon naught square. Just multiply. This is the potential energy we have. This is a potential energy. I'm just cross checking this. I don't want to commit any mistake. That's the reason I'm cross checking each and every equation. This is equation number 4, I hope, right? And I'm going to find out the kinetic energy. How to find out this kinetic energy? Let's see. As we know that kinetic energy is equal to half mv square. Half mv square. Kinetic energy is equal to half mv square. Today the class will be little lengthy. Why? Because I'm just taking 2 classes in single classes. రెండు క్లాస్లో తీసుకోవాల్సిన టాపిక్ మొత్తం కూడా ఒకటే క్లాస్లో ఫినిష్ చేస్తున్నాను. ఎందుకంటే ఆల్రెడీ మనం 2 క్లాసెస్లో టైం వేస్ట్ చేసాం. ఎందుకంటే నాకు ఫస్ట్ ఒక క్లారిటీ రావాలి. నా వీడియో క్లారిటీ ఎలా ఉంది, లౌడ్ అంటే వాయిస్ ఎలా ఉంది తెలియాలి. అండ్ నాకు కాన్ఫిడెన్స్ కూడా ఉండాలి, కాన్ఫిడెన్స్ లెవెల్స్ ఉండాలి. కాబట్టి 2 వీడియోస్ని కూడా అంటే నేను లైట్ తీసుకుంటున్నా. మళ్ళీ సేమ్ టాపిక్స్ ఇందులో మీకు టీచింగ్ చేస్తున్నా. సో టేక్ దిస్ వీడియో యాజ్ ప్రాంప్ట్. ఓకే, ఆ వీడియోస్ పక్కకు పెట్టేసేయండి. ఈ లెక్చర్ వినండి, ఇక్కడ నుంచి లెక్చర్స్ వినండి. ఓకే, అండ్ హాఫ్ mv స్క్వేర్ అండ్ వాట్ ఈస్ ద వెలాసిటీ ఈక్వేషన్? Ze స్క్వేర్ by 2nh epsilon naught. Velocity is Ze square by 2nh epsilon naught on a Ze square by 2nh epsilon naught for nth orbit. Okay, you just substitute this equation in the above equation. Therefore the kinetic energy is equal to 1 by 2 times of m into Z square e power 4 by 4 n square h square epsilon naught square. Squaring చేస్తాను నేను ఈక్వేషన్ అంతే. సో kinetic energy is equal to Z square e power 4 by 8 n square h square epsilon naught square. N square h square epsilon naught square. Right. And coming to this topic, see, if here we have taken an attractive force, the force directions will be different here. Okay, just a minute. Here attractive force is in this direction and apply the force in this direction. Both these forces are in opposite to each other. Yes, and the work done equation from work done equation already we have minus sign. Yes, see here as the work is done against the attractive force. Here work is done against the attractive force. Therefore here we have minus sign here. Therefore here we have minus sign here.
మహా పిచ్చి కొట్టురు కొడతా బిడ్డ నిన్ను. ఇంకోసారి డోర్ తీసి లోపలికి వస్తాయి.
Sorry, there is a disturbance because of my data. Okay, already we have minus sign here. So here in our equation, here we having minus sign, and here as both the forces are in opposite direction, we have one more minus sign here. Okay, please correct this. Minus into minus will be plus. Here we have plus. Okay, here we have minus sign. Therefore the potential energy is of negative energy. Here you will have negative energy. Please correct this one. Okay, and kinetic energy is a positive energy, and the total energy is sum of potential energy and kinetic energy. You just substitute both the equations here. Therefore the energy is equal to I'm taking my pen, just a minute. The energy is equal to, what is the potential energy and kinetic energy we have? Kinetic energy is m e power 4 z square by 8 epsilon naught square n square h square, and kinetic energy is minus m e power 4 z square by 4 epsilon naught square n square h square. If you take the LCM and rewrite the equation, you will have the energy equation as minus m e power 4 by 8 epsilon square n square h square. Here you will also have z square. Okay, this is the energy equation. You have energy equation. Okay, yes, this is the energy equation for nth orbit. This is equation number, what is the equation number here? Kinetic energy is equation number 5 and energy equation is equation number 6. See, remember these equations. నేను బాక్స్లో పెట్టేసిన ఈక్వేషన్స్ అన్నీ కూడా మీరు గుర్తుపెట్టుకోవాలి, రిమెంబర్ చేసుకోవాలి. Then only you will be able to use these equations while solving problems. Okay, so here we had found out the energy equation, velocity equation and radius equation for nth orbits. And using this energy equation, I am going to find out the Rydberg constant. Okay, I am just multiplying and dividing this equation number 6 with hc. Multiplying and dividing this equation with hc. So therefore this energy is equal to minus m e power 4 z square hc by 8 epsilon naught square n square h cube c. hc ఉంది, multiply చేస్తే ఏమొస్తుంది, h square into h will be h cube into c. And I am taking the common values here. The mass of the electron will be common. Here e power 4, right? e power 4. And mistake చేస్తే చెప్పండి. m e power 4 hc, ఇవన్నీ కూడా కాన్స్టెంట్స్ కదా, m e power 4 hc. ఓకే, m e power 4 hc z square divided by 8 epsilon naught square c h cube, 8 epsilon naught square c h cube. Okay, divided by n square. Okay, this constant that is m is the mass of the electron, E is the charge of the electron, epsilon naught is the permittivity of disperse, U is the speed of the light, and h is the Planck's constant. If you substitute all these values, you are going to have a constant value. You are going to have a constant value which is nothing but a Rydberg constant, So this Rydberg constant is nothing but me square 8 epsilon naught square, me square by m e square by 8 epsilon naught square CHQ, whose value is 1.09737 into 10 power 7 per meter. This is the value of Rydberg if you substitute all these constant values. Should I give the constant values? Mass of the electron. What is the mass of the electron? 9.1 into 10 power minus 31 kg. Planck's constant H is equal to 6.63 into 10 power minus 34 joules a second, and epsilon naught value is 8.85 into 10 power minus 12 coulomb square per Newton meter square. Speed of light is 3 into 10 power 8 meters per second. Okay, charge of the electron is 1.6 into 10 power minus 19 coulomb. If you substitute all these values, you will be able to find out the Rydberg constant value. Okay, just substitute all these values and find out the equation value of Rydberg constant. Okay, therefore you can rewrite this energy equation here. Energy equation, I am rewriting this energy equation. Energy equation for nth orbit in terms of Rydberg constant is minus R infinity hc z square by n square. This is one more important equation for your examinations. Okay, and for hydrogen atom, Bohr's atomic model is for only one electron system, one electron atom. Hydrogen atom contains one electron, and for first orbit, now so I'm taking this in values, all the values, not only for first orbit up to infinity. The energy will be equal to, if you substitute the Rydberg constant value, Planck's constant value, and speed of light value, this will be equal to minus 13.6 z squared by n square. This equation is valid for any atom, not only for single electron atom, it will be valid for any atom. And for hydrogen atom, the energy is equal to minus 13.6 by n square. If you substitute the z value, this is the energy equation for hydrogen atom. You have to remember all these equations. బట్టి పట్టని అవసరం లేదు, ఆటోమేటిక్గా ప్రాబ్లమ్ సాల్వ్ చేసే కొద్ది ఎక్కువ ప్రాబ్లమ్ సాల్వ్ చేస్తే అన్ని టైమ్స్ మీరు ఈక్వేషన్ యూజ్ చేస్తారు కాబట్టి ఆటోమేటిక్గా మీ బ్రెయిన్లో ఉండిపోతుంది. డోంట్ వరీ, ఆల్ దీస్ ఆర్ వెరీ ఇంపార్టెంట్ ఈక్వేషన్స్. సో యూజింగ్ దీస్ ఈక్వేషన్స్ యూ క్యాన్ ఫైండ్ అవుట్ ది గ్రౌండ్ స్టేట్ ఎనర్జీ. Okay, this energy E1 is a ground state energy. For n equals to 1, you will having E1. This will be equal to minus 13.6 electron volts for n equals to 1. This is for n equals to 1, and for n equals to 2, you will be having minus 13.6 by 2 square is 4. The value is minus 3.4 electron volts. And for infinity, n equals to infinity, the value of the energy for infinity orbit is equal to 0. That means the electron in the first orbit carries minus 13.6 electron volts. And if you want to remove the electron from this first orbit, you have to use 13.6 volts of energy. That means the energy requirement for removing the electron from first orbit is 13.6 electron volts, and the energy requirement for removing the electron from infinity orbit is equal to 0. అంటే జీరో మీరు ఏ ఎనర్జీ యూజ్ చేయకుండా ఆటోమేటిక్గా మీరు ఎనర్జీ ఎలక్ట్రాన్ని రిమూవ్ చేసేయచ్చు. దట్ మీన్స్ I will explain here one point, very important point. See, we are having infinity number of electrons. If we are having infinity number of orbits, sorry, not electrons, infinity number of orbits. Okay, so for n equals to 1, n equals to 2, n equals to 3, n equals to 4 orbit up to n equals to infinity, and here you will have zero energy. E2 is E0 is minus 13.6, right? E0 is minus 13.6, and E1 is minus 3.4, and so on, and infinity, for infinity the energy will be equal to 0 for infinity orbit, right? So listen carefully here. The energy requirement for removing the electron from first orbit is the plus 13.6 electron volts. Okay, so you have to use the opposite energy, and negative energy ni మనం పాజిటివ్ ఎనర్జీ యూజ్ చేస్తే మనం ఎలక్ట్రాన్ని రిమూవ్ చేయొచ్చు. ఇది 13.6 ఎలక్ట్రాన్ వోల్ట్స్ అనేది చాలా ఎక్కువ ఎనర్జీ కంపేరింగ్ టు దిస్ ఎనర్జీ. ఓకే, ఇక్కడ జీరో ఎనర్జీ యూజ్ చేస్తున్నాం, ఇక్కడ వచ్చేసి 13.6 ఎలక్ట్రాన్ వోల్ట్స్ ఎనర్జీ యూజ్ చేస్తున్నాం. అంటే ఇక్కడ చూడండి, ఇన్ఫినిటీ లెవెల్లో ఉన్నప్పుడు ఎలక్ట్రాన్ మనం ఈజీగా రిమూవ్ చేయొచ్చు. ఎందుకు అంటే హియర్ if I'm considering this as the nucleus, and here I have an electron, that too in infinity orbit. This electron is not bonded to this electron, neutron. ఇప్పుడు నెగిటివ్, ఇప్పుడు మనకి ఫోర్స్, కూలంబిక్ ఫోర్స్ ఆఫ్ అట్రాక్షన్ చూసినట్టయితే అందులో మనకి నెగిటివ్ ఉంటుంది 1/4πε0. ఫోర్స్ విల్ బి మైనస్ సైన్ 1/4πε0 Zg²/r² ఉంటుంది. సో ఈ మైనస్ సైన్ దేన్ని రిప్రజెంట్ చేస్తుంది అంటే attractive force. Minus sign represents that this force is an attractive force. అందుకే ఇక్కడ వర్క్ డన్ లో మనకి కొంత కన్ఫ్యూజన్ వచ్చింది. వర్క్ డన్ రిలేషన్ ఫైండ్ అవుట్ చేసినప్పుడు కొంత కన్ఫ్యూజన్ వచ్చేసింది, ఎందుకంటే మనం అక్కడ ఇది అట్రాక్టివ్ ఫోర్స్ అనేది కన్సిడర్ చేయలేదు కాబట్టి ఆ చిన్న కన్ఫ్యూజన్ అయితే వచ్చింది. సో డోంట్ వరీ. వేర్ ఈజ్ అవర్ స్లైడ్? సారీ. ఓకే, డన్. సో ఇది అట్రాక్టివ్ ఫోర్స్ కాబట్టి ఎలక్ట్రాన్ న్యూట్రాన్ అయితే బాండ్ అయి ఉంటుంది. సో ఫస్ట్ ఆర్బిట్లో 13.6 ఎలక్ట్రాన్ వోల్ట్స్ ఉంటుంది ఎలక్ట్రాన్కి, మైనస్ 13.6. సో ఇవి రెండు కూడా బాండ్ అయి ఉంటుంది. ఎక్కువ నెగిటివ్ వీటీ ఉంటే, ఎంత ఎక్కువ నెగిటివ్ వీటీ ఉంటే అంత ఎక్కువ బాండ్ అయి ఉంటాయి ఎలక్ట్రాన్ ఉన్న న్యూట్రాన్స్. ఓకేనా, ఎలక్ట్రాన్ న్యూక్లియస్కి అంత ఎక్కువ బాండ్ అయి ఉంటుంది. సో యాజ్ యూ మూవింగ్ టు ద హైయర్ ఎనర్జీ లెవెల్స్, what happens? The energy negativity decreases. The negativity of the energy decreases. Therefore, the electrons will not remain bonded to this nucleus. ఈజీగా రిమూవ్ చేయగలుగుతాం మనం హైయర్ ఎనర్జీ లెవెల్స్లో. అదే లోయర్ ఎనర్జీ లెవెల్స్లో ఎలక్ట్రాన్ స్ట్రాంగ్గా బాండ్ అయి ఉంటుంది న్యూక్లియస్కి, కాబట్టి మనం రిమూవ్ చేయడానికి కాస్త ఎక్కువ ఎనర్జీ యూటిలైజ్ చేయాల్సి ఉంటుంది. ఓకే, ఇక్కడ చూడండి, ఇక్కడ 13.6 ఎలక్ట్రాన్ వోల్ట్స్ యూజ్ చేస్తున్నాం మనం ఎలక్ట్రాన్ రిమూవ్ చేయడానికి. అంటే ఇక్కడ కమింగ్ టు అయనైజేషన్ పొటెన్షియల్ ఎనర్జీ, కీప్ ద హెడ్డింగ్ అయోనైజేషన్ పొటెన్షియల్ ఎనర్జీ. ఇప్పుడు మనం ఎంత ఎనర్జీ యూటిలైజ్ చేస్తున్నామో రిమూవ్ చేయడానికి, ఆ ఎనర్జీని ఏమంటామంటే అయనైజేషన్ పొటెన్షియల్ ఎనర్జీ అంటాం. So how to find out this ionization potential energy? If you subtract the ground state energy from the infinity energy, that is 0 minus of minus 13.6 electron volts. This is for hydrogen atom. Okay, confuse avakandi. So therefore the ionization potential energy is plus 13.6 electron volts. Okay, this energy is required, this much of energy is required to remove the electron from the ground state of hydrogen atom. And not only that, this energy is nothing but binding energy. బైండింగ్ ఎనర్జీ అని కూడా అంటాం. ఎందుకంటే ఇంత ఎనర్జీ రిక్వైర్మెంట్ ఉంది మనకి, అంటే ఇంత ఎనర్జీ ఉంది ఎలక్ట్రాన్కి, న్యూక్లియస్కి బైండ్ అయి ఉండడానికి ఇంత ఎనర్జీ ఉంది ఎలక్ట్రాన్కి. సో సేమ్ అమౌంట్ ఆఫ్ ఎనర్జీ మనం యూటిలైజ్ చేస్తే మాత్రం ఎలక్ట్రాన్ని రిమూవ్ చేయగలుగుతాం. దీన్ని ఏమంటాం మనం బైండింగ్ ఎనర్జీ అని కూడా అనొచ్చు. సో దేర్ విల్ బి ఓన్లీ వన్ అయనైజేషన్ పొటెన్షియల్ ఎనర్జీ ఫర్ ఎవ్రీ ఆటమ్, బట్ దేర్ విల్ బి డిఫరెంట్ ఎగ్జైటెడ్ స్టేట్స్ ఎనర్జీ. ఫస్ట్ ఎగ్జైటెడ్ స్టేట్కి లో ఎనర్జీ ఏంటి, సెకండ్ ఎగ్జైటెడ్ స్టేట్కి ఎనర్జీ ఏంటి, ఎగ్జైటెడ్ స్టేట్ అంటాం. సరే, ఫస్ట్ ఎగ్జైటెడ్ స్టేట్ ఎనర్జీ, ఫస్ట్ excited state energy. First excited state energy ఏంటి అంటే energy will be equals to G2, అక్కడ ఇన్ఫినిటీ మైనస్ E2 చేసామనుకోండి మనకి ఫస్ట్ ఎగ్జైటెడ్ స్టేట్ ఎనర్జీ వస్తుంది. మీరు చేసేయండి. I don't want to waste time and I have to move on. I have very less time to teach you. This will be minus of minus 3.4. First excited state and the state energy enti 3.4 value. And coming to our next topic, I just want to start our next topic. Before going to start our next topic, I want to give you a work. Copy these questions. You have to solve these questions. How much energy is required to remove an electron from a H plus atom in a state with n equals to 5? n ఈక్వల్స్ టు 5 స్టేట్లో ఉన్నప్పుడు ఎలక్ట్రాన్ రిమూవ్ చేయడానికి మనకి ఎంత ఎనర్జీ రిక్వైర్మెంట్ అవుతుంది? దట్ టు ఫర్ హీలియం ప్లస్ ఆటమ్. హీలియం ప్లస్ ఆటమ్కి వాట్ ఈస్ ద జెడ్ వాల్యూ? యూ హ్యావ్ టు సెర్చ్ ఇట్, యూ హ్యావ్ టు ఫైండ్ అవుట్ ఇట్ అండ్ టు సాల్వ్ ది ఎనర్జీ రిక్వైర్డ్ టు రిమూవ్ ద ఎలక్ట్రాన్. ఓకే, అండ్ ఆల్సో see here I thought that sorry. సో ఫస్ట్ ఎగ్జైటెడ్ స్టేట్లో ఉన్నప్పుడు ఎనర్జీ రిక్వైర్మెంట్ మనకి ఎలక్ట్రాన్ రిమూవ్ చేయడానికి 3.4 ఎలక్ట్రాన్ వోల్ట్స్ అవసరమైంది. ఇన్ ద సేమ్ వే ఇన్ అవర్ క్వశ్చన్ n ఈక్వల్స్ టు 5 స్టేట్లో ఉన్నప్పుడు దట్ టు ఫర్ హీలియం ప్లస్ ఆటమ్లో n ఈక్వల్స్ టు 5th స్టేట్లో ఎలక్ట్రాన్ ఉన్నప్పుడు మనకి ఎంత ఎనర్జీ రిక్వైర్మెంట్ ఉంటుంది ఎలక్ట్రాన్ రిమూవ్ చేయడానికి అనేది క్వశ్చన్. ఓకే, and coming to next question, calculate the ionization potential energy for helium plus atom, lithium plus atom and positonium atom. I will give you a hint here. For helium plus Z value is 2 and lithium plus Z value is 3 and for positonium atom it will be equal to 1. ఇంకా చూడండి ఆల్రెడీ చెప్పేసాను నేను Z value. Okay, just solve these questions. You have to find out the ionization potential energy. Ionization potential energy ఎలా find out చేస్తారు? Infinity minus E1. This will be the ionization potential energy. Ionization potential energy is nothing but binding energy. And coming to our next topic, hydrogen spectrum. I will move little faster. Hari, good morning. Thank you. Explanation is easily understand. Thank you so much, Hari. Narmada, fabulous teaching, ma'am. Thank you. Thank you so much, Narmada. So coming to the hydrogen spectrum. The hydrogen spectrum is hydrogen contains one electron. This can also said to be one electron spectrum. One electron spectrum అని కూడా అంటాం మనం. It was given by Bohr. Bohr did his experiments and found out that hydrogen spectrum. Okay, and these are the different energy levels. Okay, different orbitals n equals 1 orbit, 2 orbit, 3 orbit and so on infinity orbit levels. And we have the energy for hydrogen atom. The ground state energy is minus 13.6 electron volts and infinity for infinity orbit the energy will be equals to 0. So whenever you observe through the spectrogram, see if I have taken a glass tube and I fill this glass tube with hydrogen gas. I'm taking here the hydrogen gas and I illuminated this glass tube continuously with the light rays. Okay, so here the hydrogen gas absorbs and emits radiation. Here you will have the absorption spectrum as well as the emission spectrum also. Okay, it will absorb and emits radiation and you will have a spectrum here that is a dark line spectrum, and the background contains the bright one. Background is the bright one, and you will have the dark line spectrum. Okay, and you will have a line spectrum. Lines అంటున్నా continuous spectrum కాదు ఇక్కడ, ఎందుకంటే continuous emission అవ్వట్లేదు light. Okay, it is observed and then emitted. It is observed and then emitted. Therefore, we will have a dark spectrum, dark line spectrum here, and we are having the series of spectrum, different series of spectrum, that is a Lyman series. This is a Lyman series. Then after Balmer series, Paschen bracket Font series. We had already learned this in our previous classes, not by me, not taught by me. In your intermediate or in your graduate level, you had already learned this. Okay, listen carefully here. So for Lyman series is possible only when the electron transmission takes place from higher orbits, that is n equals to 2, 3, 4 and infinity, to lower orbit. Okay, this is 2, n is 1. Okay, from higher orbit to the lower orbit, whenever the electron transition takes place from higher orbit to the lower orbit, you will have this Lyman series. If you observe this spectrum diagram clearly, it is mentioned here. The electron is transmitting from infinity orbit to the ground state and from 6th orbit to the ground state. So whenever the electron transmission takes place from higher orbits to this ground state, you will observe this Lyman series, and this is the only series which is observed in the absorption spectrum. This is the only series which is observed in the absorption spectrum. Why? Because the electron transmission taking place from higher orbits to the ground state. Okay, and this is also known as resonance line. Okay, Lyman series is also known as resonance line. Just why? Because see here, this absorption spectrum or resonance line is occur whenever the frequency of the absorption line and the emission line is same. The frequency whenever is same, then only you will have a resonance line. For example, ఎందుకు సేమ్ ఉంటుంది Lyman series లో అంటే, initially the electron is in the ground state and it is transmitted to the higher energy, that obviously to first excited state energy. Okay, ఎనర్జీ అబ్జర్వ్ చేసుకుంది అండ్ ఎలక్ట్రాన్ ట్రాన్స్మిషన్ అయింది. తర్వాత డెఫినెట్లీ ఇది గ్రౌండ్ స్టేట్కే రావాలి కదా. ఫస్ట్ ఎగ్జైటెడ్ స్టేట్ నుంచి గ్రౌండ్ స్టేట్కి ఎలక్ట్రాన్ మూవ్ అయింది అంటే అది ఏ సిరీస్లో పాసిబుల్ అయితే ఓన్లీ Lyman సిరీస్లో. అండ్ నాట్ ఓన్లీ దట్, ఇది ఎంత ఎనర్జీ అబ్జర్వ్ చేసుకుంటుందో అంత ఎనర్జీ రేడియేట్ చేస్తుంది డెఫినెట్గా. సో ఈ సిరీస్లో మాత్రమే అబ్జర్ప్షన్ లైన్కి ఫ్రీక్వెన్సీ ఎంత ఉంటుందో ఎమిషన్ లైన్కి ఫ్రీక్వెన్సీ అంతే ఉంటుంది. ఓకే, therefore it is said to be resonance line, and this is the only series observed in absorption spectrum. Okay, and not only that, for Lyman series you will have alpha series, beta, gamma, delta series. That means transmission taking place from n equals to 2 to 1 state. 2 to 1 state ట్రాన్స్మిషన్ అయినప్పుడు మనకి వచ్చే లైన్ ఏదైతే ఉందో దాన్ని అల్ఫా లైన్ అంటాం. ఓకే, 3 to 1 స్టేట్కి అల్ఫా బీటా లైన్ అంటాం, అండ్ 4 to 1కి గామా లైన్ అంటాం. సో ఇవన్నిటికి కూడా మనం ఏం చేయాలంటే వేవ్ లెన్స్ ఫైండ్ అవుట్ చేయాలి. వేవ్ లెన్స్ ఎలా ఫైండ్ అవుట్ చేస్తారు మరి? సో లెట్స్ సీ. వీడియో లెంత్ ఎక్కువైతుంది అనుకుంటే ఒక టాపిక్ చెప్పేసి క్లోజ్ చేస్తారు, డోంట్ వరీ. హౌ టు ఫైండ్ అవుట్ దిస్ వేవ్ లెంత్? బిఫోర్ డూయింగ్ దట్ ఐఎమ్ యూజింగ్ ద Bohr's postulate, that is V equals to initial minus E final by H. I'm going to use this formula. Okay, so energy transmission is taken from higher orbit. I'm taking higher orbit as the initial orbit and lower orbit as the final orbit. Okay, now what is the energy value we have? Energy value ఏంటమ్మా ఒకసారి చెప్పండి. Energy value, thank you so much Hari. And what is the energy value we have? Minus R infinity hc z square by n square. For hydrogen atom it will be equal to 1. I'm taking here the Rydberg constant for hydrogen atom, therefore I'm representing it with RH hc by n square. Okay, Z is equal to 1 for hydrogen atom. Therefore, this frequency, I'm taking this frequency as 1 by lambda. Okay, I'm considering it as 1 by lambda. So I'm rewriting this equation. H nu equals to nothing but the energy, okay, which is equal to initial energy minus final energy, okay, and this H nu is equal to, what is the initial energy? I'm writing here minus R infinity Hc, I'm taking common, and initial orbit is I square minus final orbit is n final square. I have taken minus R infinity Hc common. నాకు వీడియో లెంత్ ఎక్కువ అవుతుంది కాబట్టి మీకు స్టెప్ బై స్టెప్ చెప్పడానికి ప్రాబ్లం, కాబట్టి నేను ఏం చేస్తున్నా, డైరెక్ట్ స్టెప్స్ యూటిలైజ్ చేస్తున్నా. ఓకే, అండ్ వాట్ ఈస్ న్యూ? న్యూ ఈక్వల్స్ టు సి బై lambda. What is this new? New is frequency, which is c by lambda, which is equal to minus R infinity Hc into 1 by n initial square minus 1 by n final square. Okay, so cancel this Hc, therefore 1 by lambda is equal to minus R infinity into 1 by, I am taking this initial as n2 square minus 1 by n1 square. This is the formula, that is the relation between wavelength and the Rydberg constant and the orbitals. We are going to use this formula to find out the wavelength for each spectral series. Okay, so using that formula, I am writing this here, the equation. There is 1 by lambda, which is equal to R infinity times of 1 by n1 square minus 1 by n2 square, R n initial square and final square. So using this formula, you just substitute all the values. Rydberg constant, for example, I am considering this transmission, that is electron transmission taking place from second orbit to first orbit. I am just substituting these values here. That is R infinity value is 1.0937 value, and the initial is 2, that is 2 square minus 1 by 1 square. Okay, if you consider these values and solve the equation, this is yes, this is n1 square, this is n2 square. So textbooks la ilage mention chesaru kabatti నేను ఇలాగే మెన్షన్ చేస్తున్నా, don't worry. Electron transmission 2 to 1 అవుతుంది. So here n1 square and here we have n2 square, n1 value is 1, n2 value is 2 square. Okay, you just keep on substituting, you will have these values. So alpha value మనకి lambda alpha value వచ్చేసి 1216 angstroms. సాల్వ్ చేయండి, డెఫినెట్గా మీకు రాకపోతే ఏం చేయండి, నాకు కామెంట్ సెక్షన్లో కామెంట్ చేయండి, మీకు డెఫినెట్గా ఎక్స్ప్లెనేషన్ అయితే ఇస్తాను మళ్ళీ. సో ఆల్ఫా బీటా ఆల్ఫా గామా అండ్ లిమిట్, సిరీస్ లిమిట్ వచ్చేసి, సిరీస్ లిమిట్ ఎప్పుడు పాసిబుల్ అవుతుంది? ఇన్ఫినిటీ టు ఫస్ట్ ఆర్బిట్కి ట్రాన్స్మిషన్ అయినప్పుడు, రైట్? సో n2 వచ్చేసి ఇన్ఫినిటీ తీసుకోండి, n1 వచ్చేసి 1 తీసుకోండి, అప్పుడు మీకు సిరీస్ లిమిట్ వచ్చేసి 912 angstroms. The wavelength will be 912 angstroms. In this way you can find out the wavelength for each spectral series. And coming to the next spectral series, this is for Lyman series. Next for spectral series for Balmer. For Balmer series, this Balmer series is only possible whenever the electron transmission takes place from 3, 4 and so on infinity orbital to the orbital 2, second orbit ki transaction అయినప్పుడు, అంటే n equals to, this is n equals to 1, n equals to 2, n equals to 3 and n equals to infinity, so on n equals to infinity. So second orbital కి ట్రాన్స్మిషన్ జరిగినప్పుడు, ట్రాన్సిషన్ జరిగినప్పుడు మాత్రమే మనకి బాల్మర్ సిరీస్ పాసిబుల్ అవుతుంది. అండ్ దిస్ బాల్మర్ సిరీస్ ఈజ్ అబ్జర్వ్డ్ ఇన్ విజిబుల్ స్పెక్ట్రమ్. విజిబుల్ స్పెక్ట్రమ్ యూజ్ చేసినప్పుడు మనకి బాల్మర్ సిరీస్ ఫైండ్ అవుట్ చేయొచ్చు. ఇక్కడ ఒకటి కేర్ఫుల్గా అబ్జర్వ్ చేయండి, మనకి లైమన్ సిరీస్ వచ్చేసి యూవీ రీజియన్లో కనిపిస్తుంది, బాల్మర్ సిరీస్ వచ్చేసి విజిబుల్ రీజియన్లో ఉంటుంది. ఫ్యాషన్ సిరీస్ వచ్చేసి నియర్ ఐఆర్, యూ విల్ అబ్జర్వ్ దిస్ ఫ్యాషన్ సిరీస్ ఇన్ నియర్ ఐఆర్ రీజియన్, బ్రాకెట్ ఇన్ నియర్ ఐఆర్ రీజియన్ అండ్ ఫౌండ్ ఇన్ ఫార్ ఐఆర్ రీజియన్. Light is nothing but here electromagnetic radiation. అది రేడియేషన్, ఎలక్ట్రోమాగ్నెటిక్ రేడియేషన్. ఎలక్ట్రోమాగ్నెటిక్ రేడియేషన్లో మనకి డిఫరెంట్ వేవ్ లెంగ్త్స్ ఉంటాయి. ఎక్స్ రేస్, గామా రేస్, యూవీ రేస్, ఐఆర్ రేస్, విజిబుల్ రీజియన్. ఓకేనా? సో ఈ డిఫరెంట్ రీజియన్స్లో మనకి డిఫరెంట్ సిరీస్ ఆఫ్ స్పెక్ట్రమ్ అయితే కనిపిస్తుంది. దిస్ ఈస్ ఫర్ హైడ్రోజన్ ఆటమ్. ఓకేనా? సో నేను ఇక్కడ ఎక్స్ప్లెయిన్ చేస్తాను. సో బాల్మర్ సిరీస్ వచ్చేసి n ఈక్వల్స్ టు 3, 4 so on infinity to n equals to second ఆర్బిట్ కి ట్రాన్స్ఫర్ ఎలక్ట్రాన్ ట్రాన్స్మిషన్ అయినప్పుడు మాత్రం బాల్మర్ సిరీస్ ఉంటుంది. ప్యాషన్ వచ్చేసి n2 ఈక్వల్స్ టు 4, 5 సో ఆన్ ఇన్ఫినిటీ టు n1 వచ్చేసి థర్డ్ లెవెల్. ఓకే, అండ్ బ్రాకెట్ వచ్చేసి n2 ఫర్ ఫిఫ్త్, సిక్స్త్ సో ఆన్ ఇన్ఫినిటీ టు n1 వాల్యూ వచ్చేసి ఫోర్త్ ఆర్బిట్. అండ్ ఫోన్ వచ్చేసి n2 ఫర్ 6, 7 సో ఆన్ ఇన్ఫినిటీ టు n1 ఫర్ ఫిఫ్త్ లెవెల్. సో ఎలక్ట్రాన్ ట్రాన్స్మిషన్స్ సిక్స్త్ ఆర్బిట్ టు ఫిఫ్త్ లెవెల్, సెవెంత్ టు ఫిఫ్త్ లెవెల్ అండ్ ఇన్ఫినిటీ టు ఫిఫ్త్ లెవెల్కి ఎలక్ట్రాన్ ట్రాన్స్మిషన్ అయినప్పుడు మనకి ఫోన్ సిరీస్ ఉంటుంది. సో దీస్ ఈజ్ అబౌట్ ది హైడ్రోజన్ స్పెక్ట్రమ్ ఆటమ్. ఆల్రెడీ మనం క్లాస్ 1.5 hour అవుతుంది. సో ఇట్ విల్ బి వెరీ లెంతీ. సో I will continue our topics in our next class. In our next class, I am going to teach you the correction for finite mass of the nucleus. Correction for the nuclear mass. సో ఇప్పటి వరకు కూడా మనం ఏం చేసామంటే హెవియర్ న్యూక్లియస్ కన్సిడర్ చేసాము అండ్ ఇట్ ఈస్ ఎట్ రెస్ట్ పొజిషన్ కన్సిడర్ చేసాం. కానీ ఇన్ అవర్ నెక్స్ట్ క్లాస్ ఏం చేస్తున్నామంటే న్యూక్లియర్ ఐఎమ్ కన్సిడరింగ్ దిస్ న్యూక్లియస్ ఈజ్ ఆల్సో మూవింగ్. It is not fixed or at rest position, and I'm considering the finite mass of the nucleus, and I'm making the correction for our energy equation and velocity equation and radius equation, and these topics will be taught in our next class. I will teach these topics in our next class. And whoever didn't subscribe to my channel till now, you just please subscribe to my channel and share with maximum number of people, and also like my lecture. If you like my lecture, you just click on like button, so that I feel that you are encouraging me to teach you more. Okay, and if you have any doubts, please write in the comment section. I will definitely clear your doubts. ఈ సెక్షన్ లో మీకు డౌట్స్ క్లియర్ చేయకపోయినా నెక్స్ట్ సెక్షన్ లో అయినా మీకు డెఫినెట్ గా డౌట్స్ క్లియర్ చేస్తాను. అండ్ థ్యాంక్ యూ ఎవ్రీవన్ ఫర్ కమింగ్ టు మై లైవ్ క్లాస్. థ్యాంక్ యూ సో మచ్. బాయ్. Sorry, my system is not responding. I just want to close this lecture, but my system is not responding. Thank you for coming my live classes. Thank you so much. Na Telegram channel join avandi. I will provide the link in the description after completing this lecture. I will provide the link of my Telegram channel. You can download the PDF of the syllabus for your examinations there itself. Thank you everyone for coming to my live classes. You can close this lecture. I had completed the lecture. As there is a technical issue, you can close this lecture. I will provide the link of my Telegram channel. You can ఒకసారి రా. ఇది ఓపెన్ అవ్వట్లేదు, ఏం అవ్వట్లేదు సిస్టమ్. ఒకసారి రా. హలో, సిస్టమ్ ఏమైతలేదు. ఒకసారి రా అంటే ఒకసారి మర్చిపోతున్నా. మళ్ళీ తీసుకొచ్చి రీస్టార్ట్ షార్ట్ కట్ చెప్పు. సిస్టమ్ రీస్టార్ట్. షార్ట్ కట్ చెప్పు ఉంది.
అట్లా సిస్టమ్ రీస్టార్ట్ అది
నిన్న చేసావు
అనేది మొత్తం హీట్ అయింది కదా.
నిన్న చేసావు. ఏం చేసినా ఇప్పుడు?
ఆల్ట్ కంట్రోల్ డిలీట్ అవుతుంది. అయిపోలే ఇంకా
సైన్ అయిపోయింది. క్లోజ్ చేద్దామంటే వస్తుంది. ఏంటి చేయాలంట?